we go. I did it. Oh, as per usual, here's the sign-in thing. There you go. Let me go grab this worksheet. I have a couple of them on my list. I just want to go make sure I didn't miss any important ones. Worksheets and 17. Here we go. Okay, let's see, please. Let's see, which one should we do? We'll do one that deals with KSP and then one that deals with titrations. I think that should help. Let's determine molar solubility. Okay, let's do Shotly stuff. Let's do, I guess we could do number 2 on here. Let me show you what I'm looking at. I guess you could pull it up if, here, I can also just show you. I'm looking at number 2 on this chapter 17 worksheet. I'll show you here in a second. How do I do that? Oh, here it is. Okay. Number 2 is the one I'm looking at. Can I please? Yes. Ooh, too close. Okay, so we're going to determine the molar solubility. I guess I should ask, is that okay? Number 2. Those are the ones I was stuck. Good, cool. All right. Okay, so we'll do number 2 then. The markers. So we're gonna please determine R. The molar solubility of calcium fluoride, noting that the Ksp of CaF2 is 3.9 times 10 to the negative 11. Okay. All right. So I wrote that down here. Okay. The first, so we got to know what we're looking for. So molar solubility, right? Who knows where that shows up? What does that mean? What do we call it? S. Yeah, right. This is S. Right, and we do our fancy ice table. Do our fancy ice table instead of X, we write S, and we get our molar solubility. Good. Okay, so it gave us Ksp, so let's write that equation. So CaF2, that's a solid, goes to calcium 2 plus there are 2 fluorines over here, so 2 fluorine minus. Both of these are aqueous. I always forget my states. All right. Okay. Got my equilibrium. Now we can do our ice table. I guess, yeah, I'm gonna do it. Ice table. All right. Don't care about this, right? Because it's solid, so it doesn't affect my K. Okay, we have initially none of those, so zeros go there. Right. Here, since we have zeros, we put plus S and minus S. Oh, not minus S, plus 2S, right? Here's 2S, right? Because of that, my coefficient right there. Okay, so now I have S here and 2S right there. Everybody with me?
Are we just supposed to know that CaF2 is a solid?
You could check your solubility rules. So if we go back over to the worksheet, where is it? Here. I think he put it on here. Yeah, he did. All right, so we check here and we have, where is it? Should be on here. Ions containing where are my halogens? Compounds containing those, yes. Huh. Thought it was on here. Interesting. Maybe it's not. Okay. I lied. I thought it was on there. Yeah, but we can just assume since it gave us a Ksp that that's a solid right there. Or at least that's what I'm doing. We'll see if I'm right. Does that make sense? Cool. All right. Okay, so now I know that Ksp equals my Ca2 plus times F minus squared, right? Because of the 2 again, right? It's coming back. So I know that 3.9 times 10 to the negative 11 is S times 2S squared. Oh, I almost messed it up. 2S quantity squared. And so 3.9 times 10 to the negative 11 is 4S cubed And then we can solve for S, and we get S is what? Where's my calculator? Here it is. Four cube root is 2. Let me see if it's 2, probably 2.1 times 10 to the negative 4. So I got. Feel free to check my math. Got it. Cool. Let's see. Where am I? Oh, here it is. Yeah, and the rest are kind of like this, but they either ask if it precipitates. So they give you, they'll say like, oh, we're going to have a solution of some whatever 0.1 molar CaCl2, and then something else. 0.1 molar NaF or something like that, which essentially just gives you initial amounts right here, right? You get some Ca, right, coming from this guy, and you get some F coming from that guy, right? So you just get initial amounts here, and it asks if it precipitates. So you need to go and check your initial, the Q, right, with your initial amounts to see if it shifts that way. Do your KQ comparison. And I did a problem like that on Thursday. I think it was worksheet problem number 9. Yeah, number 9. I did it on Thursday, so you can go and watch me trek through it if necessary, if need be. Okay, let's see. Let's do a titration one on here. Unless there are any other questions about this. Yeah. Okay. Okay, let's do. I actually have this on my list of problems I want to do. It's from the worksheet. Oh, don't want to give you the answer. That's only for me. Okay, here's a titration one. Oh, you can't see it yet. Oh, please. Word. There we go. Okay. Number 16 on the worksheet, if you just want to look at that. I think it should be anyway. Let me make sure. Yeah, just good. So what we'll do next. Okay, what we got? We got 45.00 milliliters of 0.240 molar HOCl, and we have 0.250 molar OH minus. The pKa of this is 7.54, and I want to know the pH. Salvage that. Equals what at the equivalence point. Okay. Make sure I didn't miss anything important. Nope. Okay. Okay. Here's all the stuff. Basically, I summed it up. Excuse me. Okay, who knows what to do first? Right? You're guessing that was right, your equation, yes. Okay. So we have our HOCl plus OH minus goes to, excuse me, OCl minus plus H2O. Right? Okay, now what? Need to find the moles. Yeah, find HCl. Yeah, good. Finding the moles of HOCl. Okay, that's good. So let's do that. Do it different. So we have 45.00 milliliters. Oh, I'm just going to do it quickly. So I have 0.045 liters. That times my 0.240 molarity. And that will be moles, I think. Yeah. That's 0.0108 moles of HOCl. So I'm going to put that right here. Okay. Not too bad, nothing too bad yet, right? Erase. Right, okay. Nice and quick. So how do I know my moles of OH minus?
Do you have to find the equivalence volume?
I have to find the equivalence volume, yes. Yeah, that's something I have to find the volume, right? And what's my, how do I get equivalence volume?
You set it equal to the moles you got of HOCl.
Right, yes. Okay, so these moles are going to be the same, OH minus. So 0.01008 moles. To get my volume, I want to do, hold on, let me, molarity is moles, liters. So I want to do
The same number of moles for both of those?
yeah, because we're at the equivalence point, right?
Okay.
Right. That's moles of acid is the same as the moles of base at the equivalence point. Right, that's true. Okay, and then I know that if I take 0.0108 moles divided by my molarity, so 0.0 or not 0.250 molarity, I get my volume is 0.0432 liters. Right, so that's what? We'll keep tabs, 43.20 milliliters. Everyone with me so far? Yes, yes, good. All right. Okay, so we have, where am I? What's this? Okay. Right now our limiting reactant problem, really easy. Same for both of them. So it's just whichever, pick your favorite. Actually, both of them are limiting, right? Boop, 0 plus 0.0108. None of that, and all of this, 0.0108 moles. All right. So for finding pH, we need concentrations. So what are we going to divide this guy by to get our concentration? Total volume, good. So that's 45 plus 43.2, and I got 88.2 milliliters. So that's 0.0882 liters. So I got 0.0108 over 0.0882. I get 0.122. Yeah. Maybe I'll keep 4. We'll do an extra one. 224. Yeah, we'll keep 4 sig figs. Why not? Extra one. Okay. All right. Now it's just finding the pH of this molarity of that weak base, right? Right. Like just like chapter 16. So let's see. Let's do so OCl minus plus H2O goes to sorry, had a brain fart there. Okay, plus OH minus, my ice table. Okay, about that. My 0.1224 goes there. 0 of that, 0 of that. Minus x plus x plus x. Okay, 0.1224 minus x, x and x. Okay, nothing too different right there, right? Let's see. So I need a KB. And there are, okay, so I need a KB, so let's get KA, right? So KA, because it gives us pKa. So let's do KA equals 10 to the negative pKa. So Ka is what? 10 to the negative 7.54. And what's that? 2.9 times 10 to the negative 8. That's 8. Again, feel free to follow along and check my math. And then KB is our KW, so that's, or is KW over KA, so 1.0 times 10 to the negative 14 over 2.9 times 10 to the negative 8. So KV is what? What is it? Right. 3.47 to the negative 7. Okay. Stop me if feel free to stop me if I'm doing something that doesn't make sense. Okay. Okay, so now we can solve this finally. So I'm going to go ahead and make, so that's 10 to the negative 1, 10 to the negative 7. I'm going to make my x a small assumption. So I'm going to say that 3.47 times 10 to the negative 7 is x squared over 0.112, or not 122, 224. And so X is what? I'll keep 4050 times 10 to the negative 4. Got to make sure that's less than 5%. I've been getting lazy on that recently. That's okay. 10 to the negative 4 over my 0.1224 times 100. Save space here. That is 0.167%, which is less than 5, which is good. Almost there. And we finally, okay, so I can get my POH right. It's OH concentration, so I can get POH was negative log of, oh, I'm gonna run out of space. POH equals negative log of 2.050 times 10 to the negative 4, yeah, which is 3.6, I want 4 after 884. So, and then 14 minus, so my pH gives me 10.3116. Bam. Okay, here's a sanity check. Okay, that's a basic pH, right? And we are adding a strong base to a weak acid. And, you know, since we're adding a strong base, you would expect the strong base to pull the equivalence point more towards the basic side. So that makes sense. That's what I'm saying. Done. Questions? Nope. No. Awesome. Okay. So now that we've done those, does anyone have questions on the chapter 18 stuff? Mainly because of the homework that's due Tuesday. Or is the homework easy? I have not looked at it yet, honestly. That's okay. It's pretty easy. Okay, good. Maybe we should, because I know you have both. You have the quiz to do by Tuesday, and then you have the homework. So I'm just trying to make sure there's enough time to talk about both, just in case people had questions about it. So maybe we'll do another worksheet problem if no one has any, if no one else opposes. please. Okay, so let's do another worksheet problem. Which one?
Can we do number 1 really quick?
Yeah. I'm always up for suggestions. Please determine the, okay, noting that the Ksp of that. All right. Okay. For those of you who don't have the worksheet, sorry, here. Is that the one? Is that the one without the answers on it? Yep, okay. Boop. Eraser. Let's see, please determine, okay, the equilibrium concentration of those two. Okay, so I'm just gonna write down the Ksp. So Ksp of AgCl is 1.6 times 10 to the negative 10. And I want to know what the equilibrium concentrations are. Then there's some conceptual stuff. What does the number really mean? What might we be able to find the mass of dissolved in water from Ksp? Okay. All right, I'll come back to that if I need it. Okay. Ooh, my knees are starting to hurt. Okay, hopefully wrote it down, took a picture or something, but I have the basic what we're looking for here. So, okay, we're looking for the equilibrium concentrations, right? So we take our thing, maybe you already did it, maybe this isn't the part you're asking about, but we'll do it. Okay, I think this one, yeah, we'll okay, that's solid. So we have our Ksp, so Ag plus, right, yeah, plus, and this is aqueous, plus Cl minus, that's also aqueous. Okay. All right. So ICE, ice table. Right, that's solid, don't care. 0, 0 for these two, plus S, S and S. So my Ksp, so my 1.6 times 10 to the negative 10 equals S squared essentially. So S is my 1.3 times 10 to the negative 5th moles per liter. I'll call it moles per liter. So both of our concentrations at equilibrium are this 1.3 times 10 to the negative 5th molar. Okay. All right, maybe, so, okay, so then what does this number really mean? Oh, we said something, got it, okay. So then the next thing is like, what does this number really mean? And this just tells us how many moles of these two things are floating in, or this is like the biggest amount of moles that can float in the water before you have some silver chloride precipitating out. So once you hit this amount, they start to precipitate out. Okay, and then it asks you about, can we possibly find the mass of silver chloride dissolved in the water? And so yes, you definitely can. You just take this and convert it into, instead of moles per liter, it's grams per liter. So we need the molar mass of this. I need molar mass. Ooh, my elbow. Okay. Ooh. Big book, periodic table. Uh, 107.9 plus 35.45. So the molar mass is 143.35. So if and this is grams per mole. So if I multiply this, so I do my 1.3 times 10 to the negative 5 moles per liter, and then times my 143.35 grams per liter, and then, or not grams per liter, got excited, grams per mole become grams per liter. So this times that, get 1.8 times 10 to the negative 3 grams per liter. So this is the number of grams of AgCl dissolved in water, or like the max, right? That's the max number of that you can have dissolved in water, or max grams, however you want to say it.
So it's the max number before it starts to precipitate?
Yes, exactly.
Okay.
Okay. Let me see what else is on here. Some Le Chatelier stuff. So if I asked you here, what would happen if I added some, what would happen to the solubility? Here, let me make sure I can see what I'm pointing to. So if I'm asking about, so what would happen to the solubility of AgCl if I added some NaCl to my solution? That's if you're looking for questions on the worksheet, that's basically number 4. Yeah, just like a conceptual thing. So if I'm wondering what happens to the solubility when I add NaCl to this solution.
The amount of Cl would increase, so it would shift to the left.
Yeah, it would shift left, and that would cause my solubility, which is essentially S, kind of. S is molar solubility, but it can be related to the regular solubility. And my solubility would go down, right? So if I add more of that, my solubility decreases. Good. All right, nice. Please determine the solubility. Yeah.
Why does the solubility decrease?
So when you shift it, oh, let me make sure I can see it. So you shift it left, right? So the amount of the value of S goes down, right? Because you're shifting it back that way. Because initially you still have plus here, so you're still kind of shifting it right, but you're shifting it less right, if that makes sense. But Here, I can show you. If I add, put a number right there. Let's put 0.1. Right? So now this becomes 0.1 plus S. So this becomes S times 0.1 plus S. That makes that a quadratic, right? So now it becomes what? 0 equals S squared plus 0.1 S plus 1.6 times 10 to the negative 10. Solve that. 1.1. Okay. Oh. Hold on. Hold on. Okay, so I get S equals 1.5 times 10 to the negative. Give me a second. 1, 2, 3, 9. 1, 2, 3, 4, 5, 6. Yeah. And then the other one is like negative 0.1. Right, ignore that one. Okay, so that's our new S. See, a lot smaller than that one. You see? Cool. Let me look at this worksheet. Unless you guys got any suggestions. I'm thinking we do number 8. Number 8 would be a good, easy one. And that kind of helps with number 9 that I did on Thursday. Does it give? Oh, it's ACL still. Oh, still the same thing. Awesome. Okay. Here we go. I don't know if you can see it, but I'm sharing it to you anyway. Okay. I'm gonna erase my stuff. We'll do number 8. I guess I don't need to erase all of it, so we can keep the ice table. What do I need? I have so I'm adding 300.0 milliliters of 0.040 molar. Oh, I'm reading the wrong one. Crap. Oops, that's not right. Number 8. So I'm looking at 500.0 milliliters of 0.0080 molar. And then we have 300.0 milliliters of 0.04. Oh, I did it again. 300. Oh, no, I didn't. Awesome. Molar, what is this? AgNO3. And then the top one is NaCl. And then it wants to know, will the precipitation of Cl minus be complete? So will the precipitation of Cl minus be complete? Okay. All right. Maybe you wrote that down or took a picture. Stop. Or maybe you have it up on your computer, whatever. Here we go. All right. So first thing, you got to know what it means when it says, will the precipitation be complete? That essentially means that it's in the next question. It tells you that the Cl minus at equilibrium is 0. The concentration of that at equilibrium will be 0. Okay. All right. So first off, what we'll need to do is calculate. So we need to calculate some new concentrations here because we're mixing these two things together, right? So I need to figure out the concentration of Ag plus, and then I need to figure out the concentration of my Cl minus. Okay. So let's do that. So this is aqueous. I'm just going to assume that we're going to do our basically M1V1 equals M2V2, right? For both of those. So for my Ag plus, so my M1 is 300 milliliters, and then, or my V1, my M1 is 0.040 molar over my, what is going to be 800 milliliters. It's going to get me 300, 0.040, 800, 0.015 molar. Okay, 0.015. Also, I don't know if you were told this when he taught you the M1V1 thing, but you can put milliliters here and it doesn't matter. Cl minus. Same thing, so we have our 500 milliliters times our 0.008 over my 800 milliliters. Okay. What's that going to give me? 500 times 0.008 over 800. So I get 0.005 molar. Everyone with me? Or any questions, I mean?
How do you know that you need to put concentrations in the initial? Because like in the last problem we just put 0. So why do we need to put actual numbers there this time?
Here it's saying we're mixing these two things, right? We're mixing, where is it? Yeah, well, I'm adding the NaCl to my AgNO3, right? So I'm mixing these two things. In my last problem, I just said determine the equilibrium concentration of Ag, or probably, and yeah, it just said determine the equilibrium concentration in water, essentially, right? I'm not mixing anything together. I just have like AgCl in water. Right. Okay, then we do, I'm gonna erase this so I have more space. We do our thingy, like we do plus S, or wait, now we have to, God, should check myself. Now we actually have to check to see which way this thing is shifting, right? Because I don't have zeros right there, so I can't just assume it's going to shift or shift this way. What I mean, so do our K and Q. So K versus Q. So 1.6 times 10 to the negative 10. Oh. And then Q is just those two times each other. Oh, no problem, Luis. He left already. I don't know why I said that. Maybe he'll watch the video. And this is 7.5 times 10 to the negative 5th? Yeah. Okay. Right, Q is greater than K, so it's going to shift right still. So that's good. If it was the other way around, if we got that K was greater than Q and it didn't shift left, then we would stop, because there's no way that we would have gotten all of this would precipitate it out if it was shifting towards my product side and I had plus S here, right? There's no way this becomes 0 by adding a number. But we have the opposite, so we have negatives here. Right. Okay. Get rid of this. Right. We do our so I get 0.015 minus S, and then 0.005 minus S. Okay. And then I have, now I do my K, so I get that 1.6 times 10 to the negative 10 equals my 0.015 minus S times my 0.005 minus S. Okay. And I gotta do algebra now. 1.6 times 10 to the negative 5th, or 10, equals, God, I just found this, 7.5 times 10 to the negative 5th. That's just those two multiplied together. And then minus 0.02 S plus S squared. So I get 0 equals S squared minus 0.02 S plus, what's this, minus 10 to the negative 10. Oh, it's the same thing. 7.5 times 10 to the negative 5th. Or at least that's what my calculator rounded it to. When I solve this, I'm going to get S is 0.015 and then, or 0.005. Right? Noticing that these are both of those. Essentially, that's 0, basically, right? I subtracted it and I got this in my calculator. I got the same thing back. So it's almost negligible. Still doing our math here. So okay, can't be that one. That one's too big. It's going to get us a negative number right there. So it has to be this guy, right? So again, we're doing all this because we want to know what the amount of Cl minus at equilibrium is. And oh boy, look at that. It's 0. So my Cl minus equilibrium is equal to 0.005 minus 0.005. So my Cl minus at equilibrium is 0. So the precipitation of Cl minus is complete. And there it is. There's like my answer.
So will it always have to, the concentration always have to be 0 for a precipitation to be complete?
Yes. At equilibrium. But yeah. Any other questions about this? Like I said, I did another problem like this. I think it's the next one, literally, on like number 9. It's kind of the same question, where they ask if the precipitation is complete for one of the ions. Got it. Cool. Well, if you guys have no other questions, we can be done. But yeah, don't forget about the homework, and feel free to message me if you have any questions about that. No problem, everyone. See y'all later.